All right, a possible solution for that challenge problem that I gave you most recently. We're looking for a parallelogram to have an area of 24. We know to get area, it's base times height. So basically, I just need the base and the height to be two numbers that can multiply to equal 24. I'm thinking I'm going to make the base 6, and I'll make the height 4. 6 times 4 is 24, so that will work. All right, and I wanted to encourage you to use some positive and negative numbers. So I'm going to go to the different quadrants here to get positives and negatives. Maybe if I go to right there, which is at -3, -2, that could be the first point. We want the base to be 6, so I'm going to go 6 this way, straight across. So if I go 6 that way, it's going to take me to +3, -2. And there's the base of my parallelogram. Some of you guys listed a rectangle, which is a parallelogram. If I want to make this a rectangle, I would just make sure this line goes vertical. I'm going to make mine a little bit more interesting, though. I don't want there to be a right angle. I do want the height to be 4, so I'm going to go up 1, 2, 3, 4, but I think I'll also go over just 1 right there. So it kind of goes a little bit diagonally there instead of straight up vertically. But it still gives the height of my shape. The height is 1, 2, 3, 4. Okay, so this point is -2, -2. No, I'm sorry, -2, +2. All right, so to complete the parallelogram, since this one kind of went 4 up, but also 1 over, this one's got to go up 4 and also 1 over. So that's also going to be parallel to this. It's got that kind of diagonal line to it, but the height, again, is still 4. And then this will go straight across, like that. This point is 1, 2, 3, 4, 4, 2. So one possible answer for the parallelograms to have the points -3, -2, +3, -2, -2, 2, and 4, 2. And if you connect those dots, it creates a parallelogram with a base of 6, a height of 4, and the area is 24 square units. Again, just one possible answer, but there you go. Okay, so now let's do the same thing for the triangle. However, for a triangle, it's going to be base times height divided by 2. So if I try to make the base 6 and the height 4 again, 6 times 4 is 24, but divided by 2 is only 12. So I'm not going to look for two numbers that multiply to make 24. I'm going to look for two numbers that if you multiply them and divide them by 2, that equals 24. So what I'm thinking is, I know that, let's see here. I know that 6 times 4 is 24, just like that. But what about if I double the 4 to 8? So now I got 6 times 8. 6 times 8 is twice as big as 24. But then if you cut it in half by dividing by 2, then it does equal 24. So I think I'm going to look for a triangle that's 6 by 8. So I'm going to make the base 6 and the height 8. Actually, looking at the graph I made, I don't have enough room to make the height 8. So I'm going to make the base 8 and the height 6. Okay, so to make the base 8, maybe I'll make one of the coordinates right there. That's going to be at -4, -3. -4, -3. I want the base to be 8, so it's going to go 1, 2, 3, 4, 5, 6, 7, 8, all the way over to here, which is +4, -3. Okay, so from -4, -3 to +4, -3, this base is now 8. I want the height to be 6. And so it could be up 1, 2, 3, 4, 5, 6. I could put the height right there or there, really anywhere along this line would be fine. So let's say I put it right here. And connect these dots. So the height of this is 1, 2, 3, 4, 5, 6. There's the height. And this point is -2, 3. All right, so there you go. So now, if you figure out the area of this, you would have to take the base, which is 8, the height, which is 6. 8 times 6 divided by 2 equals 24, and that answers the challenge problem. And the points that I used were -4, -3, +4, -3, and -2, 3. Just one possible solution, but I just wanted to explain that to you guys. So keep a lookout on the Google Classroom, and we're going to be doing another challenge problem soon. Take care.